So this is a question on electrode potentials. Have a go working through the whole question, then review it once you've tried it and see how you've done. Starting with part A. B, C and D. And finally E. So if we take a look at part A, first thing to note is that this is a slightly unusual cell because we've got copper and copper sulfate on both sides, but what we have got are different concentrations. How does the salt bridge though provide an electrical connection between the two solutions? Very straightforward. The whole purpose of the salt bridge being there is that it allows the movement of ions. What you have got to be very careful of is avoiding talking about electrons. That would become a chemical error and you would lose the mark. Moving on to B, C and D. So on B we have got standard electrode potential 0.34. Now on the previous question, on the previous part of the question, I'm just going to jump back. You can see the overall EMF was 0.16. So if that is the case, what we're looking for is the overall difference of 0.16. So we're going to go to 0.18 volts. Now from there we can go on and look at C. Ultimately, when we talk about standard electrode potentials, we are talking about standard conditions. And one of those conditions is that the concentration is 1 mole per decimeter cubed. And that is definitely not the case in one of the half cells here, certainly. So it's all about standard conditions. In terms of the conventional representation of the cell in the diagram, again, slightly unusual on this one in the sense that they are the same half cell on both sides, but I'm going to start with my double vertical line, which represents the salt bridge. Either side of the salt bridge, I've got my copper ions, and I've remembered my state symbols. They are aqueous. I then have a phase boundary, single vertical line, with copper solid on either side of them. And if you look at that conventional cell representation, I have my copper, which is in the copper ions, which is also has the salt bridge in, which connects to the other copper ions, which has a copper electrode in. So you can almost visualize the two half cells there. In really simple terms though, the higher oxidation state will always be closer to the salt bridge. Now, moving on to the final part, part E, what we're seeing here is that the concentration of copper ions would increase on the left-hand electrode. And if you consider that, when you're then thinking why the EMF decreases to 0, if that one's increasing, the other one will be decreasing. And when we talk about voltage, we're talking about a potential difference. If there is no difference in the half cells, there won't be a voltage. And so it will come to 0 when the concentration of copper ions in each half cell is the same.